Suppose you want to send something efficiently to a distant planet in a reasonable time frame, say within 5 years. You might want to try ion engines, solar sails, anything. But what if I told you one of the fastest and most efficient ways to do the job is by riding the blast waves of nuclear charges? I'm talking about nuclear pulse propulsion. It was developed in the late 50s up to the early 60s under a governmental effort called Project Orion. The idea is simple, but undeniably something to behold. Picture a standard spacecraft, if you will. Then, instead of a typical rocket engine, imagine some sort of dispenser. That dispenser would be designed to eject small, modified nuclear charges. When they detonate, the resulting gas and vapor would press into the vehicle, creating an unorthodox, but efficient method of thrust. In order to understand how efficient it is, we need to look at how rocket engines usually function. Rocket engines are based on throwing mass backwards. Due to Newton's third law of motion, the thrust you get is equivalent to the mass you exert a force on. An engine can either burn a high mass propellant, which grants high thrusts but wastes a lot of fuel, or it could burn a low mass propellant, which can have a high velocity, but the decreased mass doesn't translate well to raw power. So, you're stuck with either having high thrust, high fuel usage, or low fuel usage, low thrust. Nuclear pulse propulsion completely circumvents this by having relatively lightweight canisters that explode and release megatons of energy. According to a NASA paper written in 2000, this method could have an ISP, a measure of efficiency, of up to 10,000 seconds. The N-Star ion engine, one of the most efficient thrusters built, has an ISP of less than half that. In spite of its advantages, people reasonably had issues with a spacecraft whose entire design philosophy centered around countless nuclear warheads. However, NASA couldn't deny its promise. There have been concepts floating around that play on this method of using explosions as propulsion, albeit with less politically debatable means. We can certainly hope to see one of those ideas take flight. Thank you for your time. Oh,